So we've got as far as this thing, the ticker tape machine, makes dots, frequency f, time period t. What does that tell us about these dots in this image? Okay, yeah, how would we get that? Yeah, with a ruler, for example. Okay, so we could just measure this with a ruler, and we'd get some distance d. What else do we know about that space? It takes one time period, okay? So it takes time t. So what can we work out from that there? Speed, exactly. So speed equals distance over one time period. Now, if all of these were the same and I wanted to reduce my uncertainty, how can I improve the way I'm doing that? Yeah, exactly. So instead of doing that, I could go to here, yeah, and then I've got my bigger D, and I've got like a multiple of t. So how many time periods is that there? Yeah, exactly. It's the spaces that matter, not the number of dots. So we would do that big and call it d2 divided by 7t would give us the average velocity over that period. Now, would we actually have a constant velocity here? We've let this thing roll down here. If we think about the mechanics of it, it's going to have weight acting downwards, mg, normal contact force acting that way, and presumably not much friction acting this way. And so it's going to have a resultant force downwards, which means it's going to accelerate downwards. So what would we expect the ticker tape to look like if we're accelerating downwards? So when it gets faster, in each time period between each press, would the tape travel further or travel less as time goes on? Yeah, because it's getting faster and faster, so it'll travel further in each similar time period. So you'd expect it to start off, then maybe we release it from rest, and it would be like that. So you're getting wider and wider. What can we work out from this? We can work out acceleration somehow, okay, and what is acceleration? Okay, do we know how to work out the velocity at a couple of points? So we could work out the velocity here, and we could work out the velocity here, and we know how much time passed between those, because, yeah, so we'll have u, we'll have v, and then there's 1, 2, 3, 4, 5, 6 time periods between those two. And so then I can work out acceleration equals v minus u over t, with t being whatever I said, 6. Happy? Just trying to work out if there's anything else we could work out. I think that's fine. All right. Let's say this ticker tape timer thing, in order to make a mark, it has, let's say, a little pencil. That's not quite how it works, but let's say it's got a pencil, and it presses down. How, in order to get these tiny little dots, what must be true? How long is it going to be pressing down for? As what? Is it pressing down for time period t? Sorry?
So like you know how the time period t
Yeah.
at the end of
Yeah, for like almost an instant in time. Yeah, okay. It's just going to press for a really small amount of time. And in practice, that is actually going to be our period of time. It's not. It's not like a time period in the sense it's 1/f, but it is gonna. It's gonna do a little, like this. Okay, and we would want that to be as small as possible, so that we can get a precise reading of the time. And that's a slightly different time to the time period that you're familiar with.
So say if it was doing those lines,
Yeah.
would you just take it from the tip of each end as you're trying to find
Really good point. Yeah. So we want to take it from the same part of each line, because that way you're measuring from the instant it lifted up or the instant it put down, which is technically an infinitesimally small period of time. Whereas if you were trying to like work out the average or whatever, it's going to be a bit more difficult. Yeah, and if you're inconsistent, then obviously we're going to have inaccuracies. Next, stroboscope. Do you know what a stroboscope is?
Does it have something to do with light?
It does have something to do with light, yeah? It's where exactly it flashes light. So it flashes light at a particular frequency. And again, we've got this idea of there's a period of there's like a frequency with which it's flashing, and within each cycle, it's on for a bit, it's off for most of it. And we want it to be on for a really small bit. What we can do with the stroboscope is cool stuff like if you've got a fan and I turn a fan on, to our eyes it looks blurry. But if you get a stroboscope to shine at exactly the same frequency as the fan's turning, it'll light up the flat fan in the same position on each turn. And we won't see it when it's dark, we'll just see it when it's lit up. So we'll just see the fan, it looks like it's completely stationary, and air's just coming out from it. Does that make sense? And you can use a stroboscope in that way. The stroboscopes allow you to adjust the frequency. You can use it to find out what frequency the fan is turning. Because when the fan stops appearing to move, you know that you found the frequency of the fan. Happy? There's something else we can do. We can use the stroboscope exactly how we've used this. I can get a ball in a dark room. I can set up a stroboscope, and then I can use a camera that has a really long exposure time, and I can drop the ball, and it will flash and see the ball here. The next flash, it'll see it here. The next flash, see it here. Next flash, see it here. Next flash, whatever, this kind of thing. And it looks really similar to the ticker tape thing that we did earlier. And if we stood up a ruler next to this, then we'd be able to take some measurements. Obviously, this is through the camera, so we have to look at the image that's produced afterwards. And the camera doesn't see anything in the intervening time because the ball wasn't lit up because it's a dark room. Happy? So from this diagram, if we had the meter rule and we knew the frequency of the stroboscope, would we be able to work out G? If I knew the frequency of flashing, would I be able to work out G? Yeah, I should be able to, because I could get velocity from that distance, and I could work out what time period it is. I could maybe get velocity from there and work out that and divide it by whatever the time period is, and then work out the time between. That might work. There could be some other thing that we do to do with Subats. Could take, if I knew it was dropped from 0, I could take U as 0 and I could work out the total time it took to hit the floor based on the strobing, and I would know the total distance, so I could do that. So there's probably a couple of other methods with that, because we can get quite a lot of information from this diagram. All right, what else could we do with the stroboscope? This is obviously one-dimensional. We could give our ball some initial velocity to the right, and then we would expect, well, how would we expect the balls to, the images of the balls to be positioned on a horizontal axis if this was projectile motion? So here, do you see how the spacing of these balls is increasing this way? How would we expect the spacing of the balls if we projected it horizontally? Like, or equal spacing horizontally, or equal to this spacing? Yeah. Okay. Nice. So let's say, for example, we're going to have one there. How many do we need to put in? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That one would go there. 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 That one. I've messed this up somehow, but you might get the approximate idea of what's going on, yeah? Right, what can we work out from this image? We did a stroboscope thing, set up a camera with long exposure, that's the image we got. What can we work out? Sorry? Yeah, we can work out the ball's accelerating. We can actually work out what the acceleration is, because we have all the same information we had here, right? Because we can read across, and we can work out the vertical acceleration. What can we work out in addition to the vertical acceleration? We've now got this horizontal component. Is there a way we could work out what the horizontal velocity is? Can we work out u? How? Yeah. I could just measure horizontal distance. Divide by 1, 2, 3, 4, 5 time periods. So, happy? Okay.